Attendees are in listen-only mode.
Good afternoon and welcome to the PASS Database Administration Virtual Chapter presentation. Today's topic is SQL Server DBA tips that can save your posterior, and this is part 2. Guy Glancer is going to be presenting today, and my name is Julie Blomquist. I assist the virtual chapter as a moderator. Our sponsor is Hewlett Packard, and we appreciate their sponsorship. PASS has a very large listing of virtual chapters. You would just go to your PASS account and associate it with a virtual chapter, and then you'll get emails on the meetings which are coming up. When you attend a virtual chapter live, you are able to ask questions. But all virtual chapters do record their sessions and they are posted on their websites. This session is being recorded. There's some exciting news in the PASS community. There's a lot of opportunities for volunteering with local groups and with the virtual groups. Go out to the PASS and take a look at how you can get involved. SQL Saturdays are one-day mini conferences that are located throughout the world. Here's a listing of those that are coming up in February and March. You could always visit SQLSaturday.com. Registration is very nominal. It usually just covers for the lunch. Like we said, there's quite a few different opportunities with PASS, with local chapters, and with the virtual chapters. PASS also has an Outstanding Volunteer Award, so if you're interested, send in your nominations along with why you think the person should be recognized. We are glad that you enjoy the recordings of our presentations. But please don't forget to become a member of PASS, and then you can get the information through the virtual chapters. Here are other ways to stay connected with PASS. And today, like I said, Guy is going to be presenting the part 2 of the tips. Guy is a SQL Server MVP and is the leader of the Israeli PASS chapter and is also the CEO of Madeira. His career has been focused on SQL Server for the past 18 years, performing various database roles either as an on-site DBA, an external consultant, or as an instructor. Guy is also involved in many activities in the SQL Server community. He occasionally speaks at community events such as TechEd and the PASS Summit, SQL Rally, SQL Bits, and the user groups around the world. He also co-hosts the SQL Server radio show. And Guy, I'm going to change the presentation over to you. Thank you.
All right, thank you, Julie. Can you see my screen?
Yes, I can. Okay,
excellent. So, hello everyone. Welcome to the second part of the session, top tips that can, well, Julie already introduced me, so you know me already. I'd just like to say a few more words about the SQL Server Radio podcast. If you're not familiar with it, I encourage you to join and listen to our podcasts. We release a show every 2 weeks, and we talk about SQL Server stuff, either a professional experience project that we did, events in the community. We interview some people from the community from time to time. Interesting stuff in case you're a SQL Server geek. Otherwise, don't do it. Don't listen to it. Before I continue, you should probably check out part 1. In part 1, I think it was in November, I had 10 tips to present. Those are all kinds of tips about SQL Server that I collected from my experience that I think are important for DBAs and that can really make a difference. And for most of them, I think that many DBAs are unfamiliar or they don't know even they exist. And I presented those tips, but I didn't have enough time. So I had time for, like, I think 6 tips to get into all the details I wanted to show. and then I ran very fast through the others. So we decided to have another one, and this is the second part. So what I'm going to do today, I'm going to review very quickly the first 6 tips, the ones that I presented last time, and then I'm going to go into more details for the last 4. I encourage you to go and watch the recording of the last session. You have the link here. Of course, we will upload this presentation, which is more or less the same, plus this slide. And also, after the previous session, there were many questions, so I wrote a blog post with all the questions and answers that were raised during the session. Then, so you have the link here as well. I encourage you to go and read. There's a lot of stuff in that blog post as well. So now we can continue to the presentation for today. Again, I'm going to review very fast, very quickly, the tips that we already talked about in the last session. So tip number 1, SQL Server setup best practices. Let me just take this out. Okay. SQL Server setup best practices. I gathered all kinds of tips about SQL Server setup when you install a new SQL Server instance. Then some of them may be trivial, some of them maybe not. First of all, if you can install SQL Server on a dedicated machine, SQL Server needs its own memory and I/O resources, and it will always perform better if it is the only major or more meaningful service on the server. Don't install SQL Server alongside other database platforms like Oracle or MySQL or other SQL Server instances, or maybe other platforms such as Exchange or SharePoint or whatever. It will perform better if you have its own service accounts for SQL Server services. It really depends on the specific version of SQL Server that you use, and Windows actually, and also whether you use an Active Directory or not. I wrote a very detailed answer about question which service accounts to use in the blog post I just mentioned, so you can read all about it there. Of course, you should install the latest updates, the latest, preferably the latest version of SQL Server, but also the latest service spec and specific build for SQL Server. You should use this website. This website details and updates all the time about the latest builds for each version of SQL Server. There is something that has changed in the past year. Microsoft has changed the policy of service specs and cumulative updates. So today, a cumulative update in SQL Server is considered tested and just like service specs. Microsoft recommends to install a cumulative update as soon as it's released to the public. So you should follow the best practices and install the latest cumulative update for your SQL Server version. If you have antivirus, and you should have antivirus on your servers, configure it to skip database files, your MDF, NDF, LDF files. There's no point in scanning those files, and it will, of course, hurt performance and interfere with your server performance. So you can configure your antivirus software to skip those file types, and you should, of course. Instant file initialization is a feature of SQL Server. It has been here for many years. It means that when you create a new data file, not a log file, just data file, or when you maybe restore a database and you need to create during the restore new data files, or even when you need to grow an existing data file, with instance file initialization, it will take 0 time. It will perform instantly. It will only allocate the space without actually bring out all the bits on disk. If you don't do it, SQL Server will have to zero all the bits on disk for those files, and it will take a lot of time, depending on the size, of course. You need to do it. There's only one risk. It has to do with security. You might create a file somewhere on disk where an old file existed before, and it wasn't really deleted because you don't zero the bits. So this might cause a security hole for some people to access information that was on the old. Concern, you should enable instant file initialization. You do it by granting the perform volume maintenance tasks privilege to the SQL Server service account. This is also part of the installation in SQL Server 2016. So now you can do it by just signing a checkbox during the installation wizard. You should leave enough memory for the operating system. This is a very important thing because by default, when you install SQL Server, it is configured to take as much memory as possible. The max memory setting will be infinite, and it's not a setting because SQL Server will not leave enough memory for the operating system to operate successfully, and this will hurt the performance of SQL Server. So this is just a rule of thumb. You should, of course, test it on your environment, but you should leave enough space for the operating system to operate successfully, and this will help SQL Server to operate successfully. So change the max memory and don't leave it as default. The recommendation here to manage the SQL Server logs, by default, SQL Server has 7 error logs, and they recycle each time you restart the server. SQL Server will recycle and start a new log file. And this is not a good configuration. My recommendation is to change it to have 30 server error logs and recycle them by a job every midnight. So then you have a SQL Server error log file for each day, and it is much easier to troubleshoot issues and to look for errors in specific days, and you don't lose any data. There is a script, there's a demo that shows how to do that. I'm not going to go into this right now. You can either watch the previous session recording or you can use the scripts to use them on your environment. Set backup compression as the default. This is not the default when you install SQL Server, and I don't see any reason not to backup compression. It has some CPU overhead, but it's really not significant compared to the I/O and the space savings that you can save using backup compression. You should, in my opinion, you should always use backup compression. So just change it as the default at the instance level. Also change the backup checksum as a default. Again, I don't see a reason not to do so. This means that after every backup operation, SQL Server will calculate a checksum value for the backup. And when you try to restore, it will make sure that the backup file is still intact by comparing the checksum values. Enable optimized workloads. This means that if you have ad hoc queries in your environment, then for the first time that an ad hoc query comes along, SQL Server will generate a plan. It will not put the plan in the plan cache. It will not consume space, only a stub with the hash value of the query. If the same query comes into SQL Server a second time, SQL Server will find a stub, it will use the second time, it will calculate the plan again, but this time the plan will be put in cache. So for all those ad hoc queries that run only once, you will not consume any space in the plan cache, and this is a very important saving. For those queries that are used many, many times, starting from the second execution, you will be able to reuse the plan in cache. Now, if you're not using any ad hoc workloads, it doesn't really have any disadvantage in this case. So again, my recommendation is always enable this setting. Also enable remote admin connections. There is a feature in SQL Server called the DAC, the Dedicated Administrative Connection. This means that if SQL Server is very busy and you can't connect to it using a regular connection, in most cases you will still be able to connect using the Dedicated Administrative Connection because it has different resources. You want to do it if you have a problem with SQL Server and you can't connect to it. In most cases, you don't have access to the server itself, and you want to connect to it remotely from a remote client. Then you need remote admin connections to be on. So it is always recommended to use this setting by default. There are some global trace flags that you should use. One of them is 1117. It means that in a file group, all files grow together. When there is a file growth operation, all the files in the same file group will go together, and they will always be at the same size, which is a recommended thing to do. Use trace flag 1118. This means that SQL Server will not use mixed extents when allocating pages for tables. It will always use uniform extents, which is always better. It will also, 1118 will also reduce the contention in TempDB. Trace flag 231, I'll talk about that later, changes the auto update statistics threshold. I'll talk about that later. It is recommended to use trace flag 2371 and 3226. Without this trace flag, every time a successful backup completes, SQL Server will write an entry in the error log. With this trace flag, it will not do it. I don't see a reason why we need all those messages. Backup was completed successfully. Now, in SQL Server 2016, something has changed. Instead of trace flag 1117, you can use the alter database command with the autogrow single file or autogrow to set those values. Instead of trace flag 1118, you can use the database option mixed page allocation. Trace flag 2371 in SQL Server 2016 is now the default behavior, so you don't need to use a trace flag anymore. This is now default. And there is no change regarding trace flags through 226, so you still need to use it as a global trace flag in SQL Server 2016. Some references. I wrote a blog post some years ago about tips for SQL Server, so some of the information presented here is in that blog post. And also I wrote a blog post about the error log management, explaining what I talked about before, having 30 log files and recycling every midnight using a job. That was tip number 1. Any questions so far, Julie?
No questions yet.
Okay, great. So I'll move on. Tip number 2, contention on allocation pages in TempDB. This is quite a common thing. If you have a busy system and you use DB a lot by either creating temporary objects, temporary tables, for example, or using all kind of internal objects, doing sort operations or building indexes, and there are a lot of operations using TempDB behind the scenes, then you might have contention. By contention, I mean, let's say you create a lot of temporary tables. When you create a new template, SQL Server has to read and modify some metadata pages in TempDB in order to control the pages allocated to those temporary tables. If many sessions create temporary tables at the same time, there will be contention on those metadata pages. The way to improve that is by increasing the number of data files for TempDB, because then each file has its own metadata pages, and you can split the overhead of those multiple sessions into multiple files. There is also always the question of how many data files should I use for TempDB. There are all kinds of recommendations over the net. Some of them are better, some of them maybe not. The best answer is you should check it on your specific environment. Test it, see what works for you, try to increase the number of files or reduce the number of files, and monitor the contention on TempDB on your environment to see what is the best value. Again, there is a demo here to show how it works. I have 2 references. One, a blog post by Robert Davis, that a very nice script, very nice query to show you how to monitor the contention on TempDB. Another one by Paul Randall, who talks about how many data files you should have to TempDB, why one of the myths of having one data file per core on your server is not always the way to go. So I recommend those 2 blog posts. And here is just, I will not run it right now, but this is the query Robert Davis recommends on his blog post to monitor the contention on TempDB. So let's move on. File sizing is a very important thing. When you start a new system, you create a new database for a new system, and also when you monitor and troubleshoot and maintain an existing system. Some things you need to take in mind. One of them is to plan ahead the size of all the database files. The data files, the log files, you need to think about how and also how many indexes it's going to have, and the log file as well, depending on the workload, the amount of transactions you are going to have, and the size of those transactions. Of course, you need to take into account your backup files as well, and everything else you're going to use in this database. Think about file growth, okay? Not just how much data you need for now, but for next year, for maybe 2 years from now, depending on how long you're going to predict. You should monitor the file growth. Then and manually grow files as needed. Don't trust the file growth in your database. Use it just as a safety measure. You don't want SQL Server to automatically increase the size of your files, because it will happen in the most inconvenient time for you, and it will consume resources. So you should monitor it, and when you think there is not enough space, you should then go ahead and manually, at less busy time, increase the size of your files. When you use autogrowth, just as a safety measure, use fixed file growth and not percentage to have a more predictable growth. and also use the max size of unlimited. I don't see a reason to use any other max size, because when the data file reaches the max size, SQL Server is going to be down. You will not be able to use it. So again, there is a script to demonstrate all of that, but I want to move forward and talk about the Arithabort problem. This is something that is very common. A lot of DBAs encounter this, and from my experience, most DBAs don't understand why it happens. And the scenario is like that. You have an application, there is some store procedure that runs for a long time. You want to troubleshoot the store procedure. It has some parameters. So what you do, you run Profiler, and you catch a sample of an execution of this store procedure with some parameter values. You copy this sample, execute store procedure into Management Studio, and you execute it to see the plan, the execution plan, and try to understand what's going on inside the plan. But then what happens is that when you run it in Management Studio, performance is great. It runs very, very fast, and you don't understand why, because in the application it takes forever. And the reason is that you get a different plan from what the application gets. Those are two different plans, and if you look at the plan cache, you can see two different plans. One is good, one is bad. And the reason is that there are all kinds of set options or kinds of settings that affect how it behaves. One of them is the Arithabort setting. Set Arithabort on or off. This affects how SQL Server behaves on all kinds of errors. If you have, for example, a divide by zero error, so it affects whether this will create an error or just a warning, and will you be able to continue to work or not. It doesn't have necessarily to do with the problematic query that you're trying to investigate, but because two sessions have different set options, each one of them will receive a different plan. And when SQL Server generates the plan, for all kinds of reasons, it might generate a different plan from other sessions. And the problem is that Management Studio has the Arithabort setting, it is set to on by default, while the .NET client driver used by the .NET application is set to false, to off by default. And this is why whenever you try to troubleshoot something using Management Studio, you will receive another plan, a different plan than the one used by the application. It might be the same plan. It will appear twice in the plan cache. In some cases, you will get a different plan, and then the problem is that you actually investigated the wrong plan. You're not really checking what the application does, and you're wasting your time. So either you change in your application connection string, change it to set Arithabort on, or change your Management Studio settings to off in order to get the same plan, reuse the same plan that application is using. You should be aware of it. Okay, this is a very common scenario. Tip number 5, monitor query statistics. I'm specifically talking about sysdm query stats. Where is it? Here it is. Okay, so this DMV, sysdm exec query stats, a very common DMV. This DMV will display all the queries that are currently in the plan cache. And for each one of those queries, it will display statistics, how many times it was executed since the last compilation, how much CPU, how much time on average this query executes, how much logical reads and logical writes, and so on and so on. A lot of metrics, a lot of statistics. It's a great DMV. You can instantly get a lot of information using this DMV to see what's going on your server, which are, for example, the top 10 queries by CPU consumption, or the top 10 queries by I/O, by reads or by writes, or the top 10 queries that most time to run, the elapsed time. You can calculate the average or maybe the max, wherever you like. So it's very, very informative. You have a lot of information there. You should take into account a few things that are demonstrated in these scripts here. One of them is that if you have a batch, if you have a store procedure, for example, with multiple statements, one store procedure with 5 statements, for example, then when you look at the text and the plan, by default, this DMV will return the entire store procedure. So you'll have 5 different rows, one for each statement, but you will see in each one of those rows the entire text of the store procedure and the entire plan of the whole store procedure. And it is hard to understand which line, which row in this DMV corresponds to which statement in the store procedure. So there are some scripts here to show you how to extract the text of the specific query and only the specific plan represented by some row. This is one thing. Another thing, you should take into account that this DMV only displays information for what's in the plan cache right now. If a query is in the plain cache for a long time, then you have statistics for a long time, maybe for a few months. If this query is in the plain cache for a few months, and it might not be what you want to look for. You want to look for statistics for the last day or for the last week. On the other hand, if, for example, you had a restart just a few hours ago, then all the cache, of course, is emptied, and now you have only statistics for the last hours, and maybe it's not good enough. Okay, so what you want to do, if you want to monitor query statistics, you need to have a job that runs every 10 seconds, every 1 minute, whatever you decide, and take snapshots of this DMV. And then you are able to calculate the differences between two snapshots, and you can look for the statistics in some period of time in history, not specifically now. So, for example, if I want to troubleshoot what happened 3 days ago, I can look at the statistics 3 days ago between 2 p.m. and 7 p.m., for example, or whatever I want to do. So everything is here in those scripts. And let's move forward. Again, I have a blog post with all the information about that and all the scripts that you can use to monitor query statistics correctly. And you can use this blog post as well. And this, again, this is the last tip that I covered deeply. About that you need to take in mind. You can use a DMV system DB index usage stats, which will give you the statistics about the usage of indexes, and you can use this DMV to look for unused indexes, those indexes that are used for writes but not for reads, and they all only incur overhead but they don't provide any value. You can check redundant indexes. This means two indexes that are either identical or maybe one of them is covering the other. So, for example, if you have an index on column A and another index on columns A and B, then the first index might be redundant, because if you look for A in your query, you can still use the index on A and B, and it can be good enough. Okay, so I have a script that can check for redundant indexes, and you might want to use it and think and see if you want to drop them. In most cases, when you have foreign keys, this means you're going to perform join operations on those foreign keys, and in most cases, you want to have non-clustered indexes on those foreign keys. So I have a script that checks for all the foreign keys without indexes, and it might be a good idea to add indexes there. There is a missing indexes feature in SQL Server. This means that whenever the optimizer has to generate a plan, it can also tell you if you had that index, this would help. And it stores that information. You can extract that information and look for the recommendations by the optimizer, but don't trust it, okay? It's not a very useful feature in my opinion. It doesn't take into account the entire workload. It's not very smart. In most cases, it will not give you very useful tips that you can think about yourself. So don't trust it. You can also use another service, another tool called the Database Engine Tuning Advisor, which is part of SQL Server Setup. And this will analyze the entire workload, so it's better than the missing indexes feature, but it's still not good enough. So don't just take all the recommendations from this tool for granted and just apply them, but think about each one and consider whether it's a good thing for your environment or not. Okay, so don't trust it blindly. Now, any questions so far?
Yes, there's a few questions regarding the error log management. When we recycle, are the logs archived somewhere for further investigation?
Yeah, so all the logs in SQL Server are archived. They are saved into the error log folder, which you can configure as part of the installation, and also afterwards using the configuration manager. And what you can do is configure how many log files you want to have there, because SQL Server will recycle. For example, if you have 10 files, then when the 10th file is filled up and the SQL Server needs to recycle, it will recycle the first file and override it, so that the information that was there before is lost. You can, of course, access the files either through Management Studio or directly by going to the.
And then there are just questions about getting the scripts, and we will post the slides, which are a link where they can download the scripts.
Yeah,
I
sure,
think you previously sent something before. Let's see, when using the sys.dm.exec_query_stats, how do I get the select statements that was run?
How do I get what? Sorry.
The select statement that was run.
Okay, so everything is in the scripts, and I also talked about it in details in the last session, so I don't want to get into more details here, but you have all the scripts there to get the statements themselves and the plans. Everything is in the scripts, in the demo script.
And can you compress a TDE database?
Can you compress a TDE? Yes, it's possible. You will not have the same ratio when the database. TDE is the transparent database encryption. It means that the entire database file is encrypted. You can compress it. You will not get the same ratio, but it's possible, yes.
Okay, why don't we move on to the new topics?
Okay, great. So tip number 7, the ascending key problem. This is a common thing that I see. In most databases, there is one or a few tables that this table is very large. It has many, many inserts, and it has some ascending key, some column. Usually it's a date and time column. Think about a transactions table or events table or something like that, and you have many, many inserts into the table. There is a datetime column, and the problem is that you have statistics on the table. You have statistics on this datetime column, and statistics is auto updated by SQL Server once in a while, and at some point statistics is updated, and let's say this table is very large. It contains data for the last 7 years. But in most cases, users only query the last week, for example. And since statistics are only updated, let's say once every 2 months, depending on the size of the table and the threshold, then after 1 week or 2 weeks, when users only query the last week, according to statistics, the last week contains 0 rows. While in reality, of course, there are many rows for the last week, and then you get a poor plan, a poor execution plan. This is a very common scenario. I see it in many, many systems, many databases, and there are all kinds of ways to solve it. Some solutions, you can update statistics manually, of course. Don't trust the automatic update behavior of SQL Server. You can have a job or even manually do it once in a while. And you can use, I talked about it before, trace like 2371. By default, the threshold of SQL Server is to update statistics automatically after 20% of the rows in the table have been modified. So, for example, if you have 1 million row table and statistics have just been updated, as soon as 200,000 rows will be either inserted or updated, statistics will be updated again automatically. Now, in very large tables, this might take a while before you hit 20% threshold. Traceback 2371 changes this behavior, and the threshold, the percentage, is not constant 20%. It is lower as much as the table becomes larger. So, for very large tables, the percentage will be much lower, and it will take less time for auto statistics to trigger. Like I said before, in SQL Server 2016, this is the default behavior now. Since SQL Server 2014, there is a new cardinality estimator. This is one of the new features, which means that the optimizer, when it has to estimate the number of rows for a specific table, it will not just look at the statistics and say, okay, for the last week I see there are 0 rows. It has, in the new cardinality estimator, it has some algorithms that identify the ascending key problem and try to estimate how many rows are there, even though statistics says there are 0 rows. So they try to address this issue. You can use filter statistics only for the last week, for example, and of course you need to maintain those. And you can have incremental statistics. I will show you everything in the demo. Let's go to the demo. And here it is. Okay, so let me move that. Okay, so I want to show you in my table using DBC show statistics. Today is February 22nd, and for the sake of this demo, the statistics is currently updated as of last week. Okay, 7 days ago. But still, there are rows in the last week in the table. I will show you in a minute. First, I'm going to use the compatibility level of SQL Server 2012. Okay, because I want to use the previous cardinality estimator, the old one. And if I use select statement, okay, and I want to look for rows in the last week in my page views table, which I also perform a join to another reference codes table. So if I look at this query, it returns approximately 195,000 rows. If we look at the execution plan, we can see that this is the actual number of, but the estimated number of rows is just 1. okay, which is like 0, okay? And this is because, according to statistics, in the last week there are no rows at all, okay? Of course, this is wrong. This is why we get a poor plan, and we get a nested loops, and we get a lot of iterations here, and this is why the logical reads in the reference table is very, very high, okay? So this is a poor plan in this case. If I change the compatibility level to SQL Server 2016, I can now use the new compatibility estimator, and without changing anything else, you will see that we get now the same results, but we have now a different plan. We now have a hash match inner join, and now SQL Server estimates this number of rows. So it's still not accurate, but it's much closer than just 0, and we get a better plan. In this case, if we look at the number of logical reads in the reference table, it's much better now than before. Okay, so this is one thing. By just upgrading to SQL Server 2014 or 2016, you can use the new kinetic estimator, which is great by itself. I should tell you that the new kinetic estimator is risky. There are many cases, many queries that with the new kinetic estimate you will get a worse plan than before. So you need to be careful with that. When you upgrade to SQL Server 2014 or 2016, you should carefully monitor the performance and the query plans that you get. In some cases, you might get worse than before, and then the best thing to do is to analyze the plans and optimize the queries and get better plans. But you also have the opportunity to use trace flag 9481. This trace flag will, for a specific query, will still use the old cardinality estimator. So even though I'm using SQL Server 2016 now, I still get the previous plan. Okay, so I can use for specific queries the previous cardinality estimator. Now, what you can do, of course, you can manually update statistics with full scan. You can do it using a job, let's say, every day. Now, for really very large tables, not like this one, this might take a time. It might take resources, and if you're running a 24/7 busy system, this might be a problem for you. But in some cases, this might be a very good solution. Just run it every day or every whatever you like. And I can show you now that the statistics is updated as of today. And now, if we run the query again, then we can see the number of rows is now quite accurate, okay, using statistics, which is now updated. So you don't have to wait for the automatic behavior. I talked about trace flag 2371. We can use that, of course, as well. I'm not going to demonstrate it here. You can use update statistics not with full scan, but with the sample. This will consume less resources, but of course it will be less accurate. So you can play with it and see if it's better or not. Let's go back to SQL Server 2012 compatibility level, and I'm going to reproduce the problem again by deleting rows from the last week, updating statistics with full scan again as of last week, and then I'm going to insert for the last week again, but because the threshold is now still 20%, statistics will not be updated automatically. So just to show you, statistics is now still updated for last week, and we are back with the same problem as before. So here is the same poor plan we had before with the estimated number of rows of 1. Now, another thing we can do is to use filtered statistics. I can use create statistics with a where clause. Okay, just create the statistics of the last week. Now this will fail because we're using a non-deterministic expression here. Okay, we cannot create a filter statistics with a non-deterministic expression. So what we can do using dynamic SQL, we can calculate the specific value for last week here, and now it's deterministic now. So this will work. Now I have a filter statistics for just the last week. If we look at the statistics itself, we can see that it's much more accurate. Okay, and it starts from February 15th to February 22nd. So it contains only the last week. It's much better because it's much more accurate. It takes much less time to calculate it, and hopefully SQL Server can use it. If I'm using now the same query, we will see that SQL Server is not able to use it, because when in SQL Server 2012 you use a non-deterministic expression here, SQL Server still can't use filtered statistics. if I'm going to change the query to use a deterministic expression as well, then hopefully the optimizer will be able to use our filter statistics now. Yes, and now you can see that the estimation is pretty much accurate, okay, which is great. I can demonstrate by using an undocumented trace flag 9204. This will display statistics used by SQL Server during optimization in the messages tab. So I can show you here. We have all the statistics loaded, including the filter statistics. Okay, so this proves that SQL Server used the filter statistics in this case. If I use it with the non-deterministic expression query, then you can see that SQL Server did not use filter statistics here. Okay, now let's go back to SQL Server 2016 and let's do the same thing again with statistics. We use a non-deterministic expression, and you will be happy to know that in SQL Server 2016 we have an improvement. So now even for queries containing non-deterministic expressions, SQL Server can use the filter statistics. So we don't have to rewrite our queries to use dynamic SQL and deterministic expressions. So this is great. Unfortunately, we cannot use trace flag 9204 in SQL Server 2016, and this is a good demonstration for what undocumented means. It is not supported anymore. It doesn't work in SQL Server 2016, so you cannot rely on it. Let's drop the filter statistics. Let's reproduce the problem again, delete the last week. This time, I'm going to update statistics, but with this incremental x1's on. This is a new feature in SQL Server 2014. And when doing this, now it means that if the are partition tables, in my case it is a partition table, then with incremental equals on, SQL Server will calculate the statistics per partition. It will still maintain a single statistics object, but it will calculate per partition, and also the threshold will be per partition. So now I can show you that statistics is for as of last week, and when I insert rows for the last week, before we saw that it doesn't trigger the auto-update statistics, but now since it's incremental, you will see that this query now has a good plan and a good estimation, and the reason is that statistics was actually updated. It's now not as accurate, okay, but it is updated because the threshold is now per partition. We inserted rows for the last week. We have partitions per day. So for each partition in the last week, for the 7 last partitions, the threshold of 20% was hit, and we had an out-of-date statistics for each one of those partitions, and the new information is merged into the single statistics object. So we have a much more accurate statistics in this case, and it also allows us to manually update statistics for single partitions, like partition 180 in this case. And of course, it will run very, very fast compared to update statistics entire table. Okay. So these are all the options we can use to solve the ascending key problem. Any questions before we go to the next tip?
Yes, there's a few questions. Hold on. I guess they cover a few. He knows the answer is it depends, but he would like to know the norm of updating statistics, how often people run the update statistics on their databases, or do they do selective table updates or a shotgun approach to update all the statistics on the tables?
Well, it's a great question, but it really depends. I see many environments and many DBAs, and each one has its own habits. I think that in most cases, for most databases, the auto-update statistic behavior of SQL Server is good enough. If you use the new behavior, the trace flag 2371, or what's now default in SQL Server 2016, I think it's good enough for most cases. For some systems, for very large tables, for example, it might not be good enough. And then what I would do, I will not disable altogether out of the statistics. I will just disable auto-update statistics for specific statistics or specific tables. And for those, I will add my own job that will update statistics manually. How often statistics? It also depends. Depends on how busy the system is. how often data changes in the table, in whether I have some low peak hours during the day or not. In most cases, I see DBAs. In those cases, they update statistics daily, but it really depends. It depends. You need to troubleshoot. You need to monitor your system to see if it's too much to do it each day. Then try to play with it. Try to change it to every 2 days, maybe once a week is good for you. It really depends on your system.
Okay, there's a few more questions, but let's move on so we can get through the presentation.
Okay, great. So let's talk about delayed durability. This is another new feature since SQL Server 2014. I think it is a great feature. What this means, if we look at how durability works before 2014, then for a fully durable transaction, this is how it was before 2014. If we have a request can be an insert statement, update, delete, whatever. This request does two things. One is update the buffer pool, update the relevant data pages in the buffer pool in memory. They stay in the buffer pool at this point. And the other one is to write an entry into transaction log for this statement. Now at first, this entry will go into the transaction log buffer in memory. There is a buffer for each database. Its size is 64K. It will first be written into the buffer, and then immediately it has to go to the transaction log file on disk to be persisted. Otherwise, we can't recover the transaction. Okay, so immediately after that, we're going to write it to the log file. During the write to the log file, we have the write log wait. Means SQL Server has to wait until the transaction is flushed into the transaction log file on disk, the LDF file, and only when the transaction log entry is in the file on disk, we get a commit. Okay, this means we have to wait. Okay, if we have another request, the same goes. We have another write log wait. We need to wait until we have a commit. Another one, another write log wait. At some point, we have a checkpoint operation which will flush with the buffer pool content into the data file, and so on. Okay, so we have a lot of write log waits. If we have a busy system doing a lot of transaction log writes, we have a lot of write log, a lot of waits because of that, a lot of locks, and we have some overrun on the system. In 2014, we can choose to use delayed durability transactions, and if we use that, it means that as soon as we have a request, as soon as the request is written in the transaction log buffer in memory, we get a commit instantly. Okay, and the buffer log, the transaction log buffer will fill up. At some point, when it's filled up, the content, okay, we have a checkpoint, of course, the content of transaction log buffer will go into disk. So we have much less round trips to the transaction log file on disk. We don't have to wait for the write log wait type, and we get commit much faster. So we have less locks, we have shorter, we have much better throughput for our insert statements and update statements on the disk. Of course, we have the risk. We have the risk of losing data. Okay, because if something happens between the time we get a commit and the time we get the data persisted on disk, something happens to the server, we lose those transactions, we lose data without being able to recover them. So this is not a good feature that for some financial transactions table. But there are lots of scenarios where you have some events table, some kind of log table that you can afford to lose some data once in a while. You can risk it, but what you get is much better throughput all the time. Okay, so you get a lot of more inserts per second, for example, into this table. There are many use cases where you can use them. Let's see a short demo. So what I'm going to do now, I'm going to use Performance Monitor. I'm going to use the batch request per second counter to see the throughput on my server. And then I have here a small batch, begin transaction, insert a single row into some table, and then commit transaction. I'm going to run it 1,000,000 times. Okay. So one row at a time. And if we look now here, we can see that we have more or less 2,000 batch requests per second. If we look at the wait statistics, this command will empty DMOS wait stats DMV. And now I have a query here that will give me all the relevant wait statistics. Okay, this means ignore all the wait statistics that are not interesting. And you can see that we have very high write log wait types. Okay, a lot of waiting tasks count, a lot of waiting time, and actually in my system, in my laptop, this is the only thing I'm running right now, we only have the write log. Okay, so we have a lot of write log, we have a lot of overhead at having to wait for the transaction logs to be persisted on disk. Let's go back here, stop this one, roll back the last transaction, if any. Okay, now at the database level, we can change the deliverability to allowed. We can also change it to forced, meaning all transactions will now be delayed. I prefer to use allowed, and then for each transaction, I can add with delay durability equals on. So I can decide which transactions become delay durable and which are not. Now let's go back to the perfmon. We can see that we have much better throughput. Okay, so this is around 4,000. Okay, so it's 2x or something like that. What we had before, we got a much better throughput. And also, if we look at the wait statistics, we don't have the write log wait type at all anymore. Okay, so we get a much better throughput, much better performance. Of course, we have the risk of losing data. Okay, so bear that in mind. Yes, cancel the query, please. Oops. Okay, let's close that. Sorry. Restart. Questions about that? Julie? Okay, let's move on. Let me just bring it back. Okay. So tip number 9, the large object storage. Okay, so the thing here is, well, let me show you the demo. Actually, it would be best to show you through the demo. So I have here a simple select statement with many columns for my operation members table. Okay, I want only the Israeli members in this case. Let's run it. So I get 20,000 rows more or less. I get a very simple execution plan, clustered index scan. Okay, for 20,000 rows, if we look at the logical reads, we have almost 30,000 logical reads, which means we had to scan 30,000 pages, data pages, okay, for getting just 20,000 rows. It doesn't make sense. Okay, this is a lot of I/O, a lot of logical reads for just 20,000 rows, and I want to know why. Okay, and okay, let's try to maybe create a non-clustered index on the country, because we want to filter by country, and I run the same query again. Okay, so it's still a clustered index scan. We still get the same number of logical reads. SQL Server chose not to use the index, okay, because in this case 20,000 rows is a lot of rows for using a non-clustered index and the lookup operator. So it prefers to use a clustered index scan. So using a non-clustered index doesn't help. I want to look at the physical stats. Okay, we have this DMV. Okay, for my clustered index, I want to see the physical statistics of the clustered index. And what we can see here that we have lob data. This lob data allocation unit means we have large data types in the table. Large object data types are, for example, n varchar max and var binary max or XML. Those are large object data types. And the way they behave by default, if you insert data, some row, into a large object data type column, varchar max, if that specific data can be put into a data page, a single data page of 8K, it will be stored in the data page itself. If not, only a pointer will be stored in the data page, and the pointer will point to a LOB data page, actually multiple pages, which will contain the actual data. Okay, this is the default behavior. So what we can see here, we see that we have this number of pages of regular data pages and this number of lob data pages. And for the regular data pages, we see that the average rows per page is 5, okay, because it contains a lot of lob data that can be put inside data pages. And it's not good for us because in this case, okay, I can tell you that we have, you don't see it here, but we have a column named picture, which has the picture of the member, the image of the member. It's var binary max, sorry. It's a lob data type. and I'm not using it in my query, but because it's in the clustered index in the regular data pages, I have to scan a lot of pages, even though I don't need most of the data on those pages because it contains the images. Okay, so what we can do, we have the SP table option. There is an option called large value types out of row. By default, the value is 0, which means if you can store the values in row, in the data page, regular data pages, I can change it to 1, meaning even if specific data can be put inside the data page, just use a pointer and put the data only in lob data pages, okay? So let's change it to 1. Let's look at the physical statistics of the index again. Nothing changes, okay? Let's try to rebuild the clustered index. Okay, so we see that some things have changed. SQL Server rebuilt the index, but it still has this number of pages. Okay, what we need to do is to update the specific column, okay, or the columns. As soon as a specific row will be updated, when we have the value of the table option set to 1, okay, so only then SQL Server will move it entirely into the lob data. So what we can do is a trivial update on the entire table. Of course, this can be risky on a production table. So you can either just set it, and whenever an update occurs, gradually rows will move into the lob data files, lob data location unit, sorry, or this update on the entire table using some mechanism of doing it in chunks every 1,000 or something like that. Let's do it for the entire table. This still doesn't change the number of pages because now we need to rebuild the entire index. And hopefully now you can see that the number of pages is shrunk, okay? So the sequence of things to do is to change the table option of value out of row to 1, update the picture or the large object types in the entire table, and then rebuild the index, and only then you can shrink the size of the clustered index. And now if I run my query again without the picture, because I don't need it, I still get the clustered index scan, but only 1/10 of the number of logical reads, okay, which is much less I/O, much better performance. So depending on the case, if you use this large object type a lot, leave it the default behavior with the option set to 0. But if you don't use the picture a lot, in most queries you don't need the picture, you don't need, I don't know, some XML file containing additional information, then prefer to use the table option set to 1, and then you don't have to scan all those pages. Okay. Any questions before the last tip?
No, why don't you go ahead to the next tip?
All right. So the last one, some refactoring opportunities. I gathered some, there are many scripts in this demo, all kinds of scripts that I usually run against databases of our customers. When I hit a new database, I want to look for all kinds of things that might require some refactoring. For example, if I see tables without a clustered index, it is a best practice to have a clustered index on each table for all kinds of reasons. So if I see tables that are heaps without clustered index, I want to investigate and see whether there is a good reason for it or not. And if there is not a good reason, let's create a clustered index on the table. I want to look for tables without a primary key. There is no reason not to have a primary key on a table. I also want to look for clustered primary keys versus non-clustered primary keys. There is a problem that the default behavior, if you create a primary key and you don't specify the type of index, by default it will be created as a clustered index. And in many cases, this is not the thing you want. You want a non-clustered index for the primary key. And many DBAs are not aware of that, or even developers in most cases, and they just create primary keys without specifying anything. So all the primary keys in the database are clustered indexes, and this is not always the good thing to do. which are more accurate. If you want to store, let's say, money, currencies, amounts of things like that, you want to use decimal and numeric. There are all kinds of problems when you use float and real, so I want to look for those and make sure that they should be used. If you use image text or end text, those are all data types from the days of SQL Server 2K. They are still here for backward compatibility, but you should not use them. I want to make sure that they are not used in any column in the database. Also, datetime and small datetime are all data types. Today we have datetime 2, we have date, we have time. We have new data types that are better in all kinds of ways than those that I want to make sure that people don't use. I still see a lot of people use datetime and small datetime and think you shouldn't use those anymore. There is some example here for primary key column that don't follow naming conventions. Foreign keys without corresponding indexes, I talked about that before. Also, redundant indexes. I want to look at non-clustered indexes with and without included columns, because many DBAs and many are not familiar with included columns, which is a great feature. I want to make sure that they use it correctly, so I look for that. So I will go quickly on those scripts. Of course, you can go through them later. You can download the scripts. So this script, for example, will return me all the tables without a clustered index in my database. Okay, so in my case, I have a few heaps, and I want to know why. Okay, so I need to investigate. This script, for example, all the tables without the primary key. Okay, for the sake of the demo, I have a few tables without the primary key. Again, I want to know why. This one, for example, all the tables without a check constraint. Okay, so most of the tables, like most databases, don't have check constraints. This table will, the script, sorry, will give me all the columns using the float and real data type. Okay, what is the name of the column, the table, and the data type itself, and I want to know why it is used like that. In most cases, experience, it's not the right way to go, and so on and so on. This uses the end text and text data types, small datetime and small datetime data types. You have all the queries here. I don't see a reason to run all of them now. You can use them later on your environment. So just to sum up this one, 2 references. I wrote a blog post about using real and float data type and why you shouldn't use them, and also how to get rid of redundant index, explaining the issue, and where you can download the script for looking for the redundant indexes. Some people asked me about parameter sniffing issues in the previous session, so I promised to include the link here. So here it is. I wrote a series of blog posts about parameterization in SQL Server. It's a very important topic. I encourage you to read the blog post. It also includes a lot of demos and scripts you can download and try them on your environment. I see many cases where people don't use parameters correctly in SQL Server, and in most cases, it has something to do with parameters one way or another. Everything is covered in this series of blog posts. I encourage you to go and read it and try it. And that's it for today. If you have any questions, this would be a great time. Julie?
So we had a couple more questions about when you covered the statistics. For the new cardinality estimator, are there differences between the 2014 CE and the 2016?
Yes, there are some differences. Microsoft improved some things about the new CE first in Service Pack 1 of 2014. And there are also some improvements in 2016. I don't think there are any changes in 2016 Service Pack 1, sorry, in the last cumulative update. But yes, there are some changes in Service Pack 1 of 2014 and in SQL Server 2016. So like I said in the beginning of this session, you should follow best to install the latest build for your version because it has all kinds of improvements, some of them related to the CE, yes.
Can I add more than one statistics on the same column, one of them being a filtered statistic?
Yes, absolutely. You can have as many as you like. Actually, in most cases, there are several statistics because some of them might be automatically created. Some of them might be created using index statistics because of index that exists. Then yes, you can have for the same column regular statistics, a filter statistics, or multiple filter statistics. There are no limitations about that.
Filtered statistics is good, but when would you create it? And would it be too late after a slow query has completed?
Well, if you have a mechanism running like a job that runs daily, and each day it will calculate the statistics for the last week and delete the previous one, then at any point in time when a query is executed, it will use the last, the best statistics, the last one, and it will still be much better than just use the regular statistics, which is not updated. Again, you can play with it, you can fine-tune, maybe you should have this job run every hour, or I don't know, depending on your environment. Anything else? Julie?
Here we are. What's the difference between the incremental statistics and the automatically updated statistics?
Okay, those are two different things. Still have automatic update statistics even when using incremental. The incremental statistics is a feature that only applies to partition tables, and it means that statistics will be updated per partition. For example, if you need to wait for the threshold of 20% before there is an auto-update statistics, there will still be 20%, there will still be auto-update statistics, but now the threshold of 20% is calculated per partition. So for example, if you have 1 billion rows in the entire table, but you have only 1 million rows for some table, for some partition, sorry. So as soon as you have 20% change in this partition will be recalculated and the information will be merged into the statistics of the table. Okay, so you still get out of the statistics, but it happens per partition now. It also allows you to manually update statistics for a specific partition if you like.
So Guy, that seems to be the majority of the questions. If you could send me the slide deck so I could also post that, or something with the URL where the scripts are that people can then download. It looks like you have multiple places that they could go for the scripts. So whatever would work best for you. And I wanted to thank you for your time, and I'll send you the question log. This is being recorded and we will post it to our archive page. We are now aware that some of the zip files from Guy's previous presentation are broken, and we're working with PASS to get that corrected. So thank you again, Guy. I appreciate it. Yes, it is very fast paced. Thank you.
Thank you.